Hello everybody, I am Professor Dr. V.K. Gupta from Scope Global Skills University Bhopal. Dear friends, you are most welcome in this series of lectures on matrices. I think this is our fourth lecture, and in this lecture we are going to discuss a new method to determine inverse of matrix. Dear friend, this method is totally different than whatever you had studied in class 12th. In class 12th, the method which was introduced to you to determine a square matrix, inversion of any matrix, it depends on the knowledge of a square matrix as well as depends on the knowledge of determining adjoint of A. In that method, actually whatever is given, you have to see whether given matrix is a square matrix or not. And if you find if it is a square matrix, then after that you have to determine its determinant value, and on the basis of determinant value of matrix A, if it is 0, then we conclude कि inversion is not defined or not possible. Then we can stop our working by answering कि inversion of given matrix is not possible. But if it is not equal to 0, then naturally inversion is possible, and inversion is possible, then निकालिए भाई, and for that we will find matrix of coefficient, सह खंडों का आव्यूह, and after getting matrix of coefficient will consider its transpose, or transpose that means rows into change in columns. जो पंक्तियां हैं, पंक्तियों को आप स्तंभों के रूप में लिखेंगे, and this transpose of matrix of coefficient is known as adjoint of A. So in this procedure, A given matrix or A square matrix is reduced in the form of adjoint of A, and this reduced adjoint of A is to be divided by determinant of A, and this division gives you a new matrix which is known as A inverse. And since we have to divide here adjoint of A by this determinant of A, that's why we had considered that determinant A must be non-zero. So that here this method contains calculation of matrix of coefficient, and matrix of coefficient requires different number of values of different determinants of less order of the order of given matrix. It is time consuming. That's why we are utilizing here new method. This method depends only on operations, basic elementary operations. Remember, these operations are either row operation at a time or column operation at a time. In previous lecture, you had seen that when we had to reduce any given matrix in echelon form, then we utilize only row operation. Or if we want to reduce given matrix in normal form, then we had to utilize row operation as well as per the requirement of column operation. But here remember and note carefully कि you have to utilize only row operation or column operation. That means यदि आपने प्रॉब्लम पे वर्क करना चालू किया है और आपने एक बार रो ऑपरेशन यूज़ किए हैं, तो आपको खत्म भी रो ऑपरेशन के साथ ही करना पड़ेगा. And by utilizing these row operations or column operation, our main aim is to reduce given matrix in the form of identity matrix of the same order. For this, let us consider our given matrix A is any square matrix. In that case, A matrix, which is square matrix, can be written in the form of A is equal to IA, where I is identity matrix of the same order of A. Suppose I am considering this relation number 1. That means A is equal to I multiplied by A. Our main aim to reduce these relation by utilizing sequences of row operations or sequences of column operation in such a way कि matrix A on left hand side reduces an identity matrix and identity on right hand side reduced in a new type of matrix. Suppose I am representing this by B. In this way, this relation number 1 becomes I is equal to BA. In this relation or in this identity, if B post multiply both the side by A inverse, we get I multiplied by A inverse, which is equal to BA multiplied by A inverse, and utilizing associative property that means any element operation second element then operation third element, and if we are operating operation in between second and third firstly and resultant is to be operated with first, this is the same just as if we operate that operation in between first two element and then resultant is operated with second. So here we have B multiplied by A, B multiplied by A and then is multiplied by A inverse can be written in the form of B multiplied by A into A inverse. And now A inverse multiplied by A or A multiplied by A inverse both always gives you the identity matrix of the same order of A. So here A into A inverse gives you identity matrix, and we will use next result of matrix कि any matrix multiplied by identity or identity multiplied by any matrix gives you the same matrix A. Therefore, B multiplied by identity gives you B matrix, and here in left hand side I multiplied by A inverse gives you A inverse. In this way we get A inverse is equal to B. That means B is the inverse of A. B is the inverse of A. It shows that कि whatever the matrix we get in place of B is our answer. To illustrate this method, let us consider example. For example, A is a square matrix of order 3 by 3 in which element in first row is 3 minus 1 minus 2 and element of second row are 2 0 minus 1. Elements are third row are 3 minus 5 and 0. To determine inverse, we will write this matrix in the form of A is equal to I multiplied by A. That means matrix A with element in first row 3 minus 1 minus 2, 2 0 minus 1 in second row, 3 minus 5 and 0 in third row, which is equal to identity matrix of the same order. That means identity matrix of 3 by 3, 1 0 0, 0 1 0 and 0 0 1. And here I am writing A as it is. Just see here A is to be considered as symbolic representation, symbolic placement. रिमेंबर आपको वहाँ ए की कोई वैल्यू या ए का मैट्रिक्स फॉर्मेट नहीं लिखना है. नाउ आफ्टर राइटिंग गिवन मैट्रिक्स इन दिस फॉर्म, that means A is equal to IA, after that we have to utilize number of row operations or number of column operation in complete procedure to reduce this matrix A into identity matrix, and respectively those operations are also applied on identity matrix on right hand side. For example, my main aim is to reduce this matrix in identity matrix. For this, I need this first position of first row and first column, that means leading element of this row, this matrix must be 1. आपको चाहिए कि यहाँ पर 1 आए, क्योंकि आइडेंटिटी में फर्स्ट रो और फर्स्ट कॉलम का पहला एलिमेंट, लीडिंग एलिमेंट 1 होता है. इसके लिए फॉर दिस सपोज आई एम कंसिडरिंग ऑपरेशन चेंज इन R1 by R1 minus R2, means 3 minus 2 is 1, minus 1 minus 0 is minus 1, and 2 minus minus 1, just here minus 2 minus minus 1 becomes minus 2 plus 1, and minus 2 plus 1 becomes minus 1 finally. So 1 minus 1 minus 1, but there is no change in second row and third row, that means 2 0 minus 1, and elements of third row 3 minus 5 and 0, and after that we will apply the same operations on this identity matrix. Here there is no change in second row, so that I am writing 0 1 0 0 0 1, and 1 minus 0 is 1, 0 minus 1 is minus 1, and 0 minus 0 is 0, and A as it is. So here we get leading element is 1, and we know very well कि first column of identity matrix, first column of identity matrix is 1 0 0 in case of 3 by 3. So next we have to reduce this element in the form of 0, as well as third, this is also in the form of 0. For these purpose, that means to reduce these matters, these element of this matrix in the form of 0, we need some other operations which must be row operations. पहले भी बताया कि एक बार यदि आप रो ऑपरेशन से शुरू होते हैं तो अगेन आपको रो ऑपरेशन ही यूज करने हैं, कॉलम की परमिशन बिल्कुल भी नहीं है. Now if we get this as 1 0 0, then next time we will utilize operations which will reduce these second and third element of first row. That means element on first row second column and element on first row third column reduces in the form of 0 and 0. And again we utilize suitable row operations to reduce element on second row second column must be 1. second row second column में ये जो element है ये 1 के form में आ जाए, and second row third column becomes 0. And lastly we will utilize suitable row operations. मैं बार बार बोल रहा हूँ सुटेबल रो ऑपरेशन, अभी मैंने ये आपको ये नहीं बताया कि यहाँ पर कौन से ऑपरेशंस यूज करने हैं. नाउ to reduce this element in the form of 0, that means element in third row second column must be 0, and element on third row, third column must be 1. In this way we get identity element, and all those row operations are also applied simultaneously on this identity matrix, and you will find out that this identity matrix reduces in any form of the matrix of the same order 3 by 3. There is no change in A. This matrix B, whatever you get, is our answer. This is the A inverse of our given problem. And you can examine whether your answer is correct or not. For that, in your rough work or rough portion, you might check, multiply A with B and check whether you get I or not. If you get identity, then your answer is correct. That means B is correctly inversion of A, otherwise not. So, you will find out in this way that this method is very easy for all those matrices which are of large size, and for that I will illustrate the same problem with the detailed working, that means all the required row operations to reduce given matrix in the form of A inverse. In next lecture, till then, goodbye.